So section 7.1, we're going to start looking at radical functions. Actually, all of chapter 7 will be on radicals. Radicals are roots of numbers, like square roots and cube roots and fourth roots, and so on. And we're really going to focus our discussion on square roots and cube roots. Okay, that's the main focus of our topic here. So the idea of a square root, most of you probably know where these come from, but just as a quick refresher, a square root is the reverse or the inverse of a square, right? So the square root is the reversing a square. And obviously a cube is the reverse of a cube. And so I'll focus on the square for a moment, and then we'll take a look at the cube idea. So you know that squaring a number, like 3 squared, is that number times itself, which in this case ends up being 9. And so a square root is going in reverse. You would take the square root of 9, which is equal to the number whose square is 9, in our case 3. Which is good, except that there's sometimes another number. If you consider the fact that negative 3 squared is also 9, because the double negative makes for a positive, then this can make for a bit of confusion. And so we're going to specify that the square root here, as written, is going to be what we call the principal square root. The principal square root is the positive one. Okay, so has positive value. Could also be 0 if we did the square root of 0, but I'm not going to really focus on that one. So we'll just consider the positive ones as the principal square root. Now, if we wanted the negative 3, because there are times where you want to have the negative one, we'll specify it by writing negative square root of 9 would equal negative 3. Okay, the negative principal square root. So this notation here is what we call the principal square root. Okay, that's the positive one. And then if we want the negative, we'll put a negative in front. So, you know, for instance, if we wanted the negative square root of 49, well, that would be negative 7, right? 7 squared is 49, and we want the negative of that. So that's the negative principal square root. Okay. What's interesting is if you take the square root of a negative number, like negative 25, again, you're looking for the number whose square is negative 25, whose square is underneath. So the question is, what number times itself would equal negative 25? Well, you might think, okay, it's got to be negative 5, right? Well, negative 5 times negative 5 is a double negative, which would make a positive 25, so that can't work. And it can't be positive 5 because a positive times a positive is also positive. In fact, there's no way to get a number times itself to be a negative number, at least when we're dealing with real numbers. And so this is, the answer to this is not a real number. Now, we're going to see later in this semester, maybe next week in fact, some numbers that we're going to make some numbers work for this. They're called imaginary numbers, but for right now, we're just going to say not real numbers. So the answer to that is not a real number. Okay? And then, of course, you can take square roots of many different things. You can take square roots of fractions, like 16 over 81. Oops. the square root of 16 over 81, take the square root of the top and the square root of the bottom, and you get 4/9. Okay. And so we can take square roots of fractions, we can do square roots of decimals, there's lots of things we can do. Your calculator can approximate these things when they don't work out nicely. Okay, so I'm not going to worry too much about the rest of this. Your calculator, however, I will mention, does have a nice square root button on it. The square root button, if you can see, is the second function of your x squared button. If you're using the TI-84s or 85s, are all very similar. Hit the second and then the x squared button, and then you can type in, if we didn't want it 49 there, it will tell us the answer is 7. And it can do the negative square roots too. If we type if you hit the negative button first and then type in your square root, you'll get the -7. Okay, so your calculator can pull these off, no problem. Now with cube roots, it's a little different. It's a similar idea though. It's the reverse of a cube. And similar idea though, you're just going to be cubing everything. So like 4 to the third is 4 times 4 times 4. 4 times 4 is 16, times 4 is 64. And so that means the cube root of 64 is going to be 4. Now the thing that's different about cube roots from square roots is that we don't need to specify a principal cube root, because cube roots always follow the sign of what's inside. If you notice, if you were to do -4, maybe I'll change my color up here. If I did -4 cubed, that's going to be 3 negatives multiplied together, which of course is equal to a negative. And so with cube roots, you can do a cube root of a negative and just get the negative value back out. So cube roots are a little bit nicer when it comes to negatives. We don't have this weird situation where you have no real number. Everything works for a cube root. Okay, positives and negatives. And of course, 0 also works, right? So you can do the cube root of 0 is 0, just like the square root of 0 is 0. And that shouldn't be a problem. Okay. In the next video, we'll look at some of the graphs of these functions and their domain and range.